Hello, this is Larry Benz, Emeritus Professor at the Ontario Institute for Studies in Education of the University of Toronto. In this short talk, I'd like to discuss STS-informed WISE engineering design and mobilization. It is my view that many aspects of our world are largely affected by pro-capitalist dispositifs, including their effects on STEM fields and STEM education. I see pro-capitalist dispositifs as largely consisting of power attributed to transnational corporations and financiers, many friendly governments and their laws and regulations, various currencies that they circulate, and of course the circulation of ideas and perspectives about how to live one's life through media controlled by the private sector. And something not often discussed in education, particularly science education, influences of transnational entities like the World Bank, World Trade Organization, and International Monetary Fund. And of course, many of these influences are also tied to work of people in STEM fields, science, technology, engineering, and mathematics. So I believe that this pro-capitalist dispositif, or this type of dispositif, has affected education, particularly STEM education, and I'd like to focus on three of those aspects of those. So STEM curriculum propaganda, for me, refers to curriculum that has been sanitized to promote STEM careers. Inquiry-based learning, which I believe to be discriminatory against those students, and there are many of them who are limited in terms of their cultural and social capital. And then civic propaganda, propaganda to limit information available to most citizens through the media, for example. Since 2006, I've been using this STEPWISE curriculum and pedagogical framework to overcome the kinds of harms that I've mentioned above. And the ultimate goal of these is to have students carry out student-led RENA projects, RENA being research-informed and negotiated action projects, to address STSE harms, that is, harms that they perceive in relationships among science, technology, society, and environment. Now, the actions that students might take in these projects, we believe, need to be informed by their own research, and so we encourage primary research in the form of correlational studies and experiments, but also, of course, secondary research. And using findings from their own research, along with their previous education, students can then develop a series of actions to address harms that they consider important. And we also, in doing that, encourage them to develop a series of actions that may work in synchrony, sort of like a mini dispositif. But we find that most students are not really ready for these kinds of projects without a pedagogy, and that's what we do here. We have the students reflect on their current attitudes, skills, and knowledge. Then we teach them attitudes, skills, and knowledge that they wouldn't easily have access to for reasons I mentioned earlier. And then we give them opportunities to practice these kinds of projects with some teacher supports rather than guidance from the teacher. And then when the students have completed their projects, they have a chance to reflect on their current conceptions, and then the teacher has a decision to make whether the students need to be taken through another cycle of this pedagogy or can be turned loose and conduct their own projects. An example of a type of project we've been promoting is WISE engineering design projects. WISE being engineering design projects that take into consideration well-being of individuals, societies, and environments. And for example, we teach them about compromises that engineers often have to make in terms of changing variables. So when they try to change an independent variable to get a desired resulting variable or dependent variable, that can accidentally or even purposely give rise to a negative result of another variable. And there are a whole series of these. But in consideration of these compromises, we ask students to consider some alternatives, and those, in this case, the teacher has chosen to use the Sustainable Development Goals from the United Nations when the students are considering their engineering designs. Now, when we imagine these engineering design projects being completed, we do not imagine that they're going to have a large effect on the way the world functions. They're like a drop in the ocean in a sense. And so that's where the mobilization of values comes into play, and our use of STS teaching. So we want students to be able to imagine mobilization of their values through actor network theory, dispositive concepts, semiotics, inscriptions, governmentality, through the panopticon concept, socio-technical imaginaries, and regulatory capture, and actually some other concepts from STS that we do teach. Now, an example of a dispositif that was developed by a teacher that I've been studying is illustrated here, where you have a series of actants that are working in synchrony, and metaphorically this watch mechanism is part of that. If you'd like to see samples of the students' projects, we have a page devoted to that, and a link to that is given here. But I'd like to have you listen to a student talk about his project before I proceed.
This is my computer mouse that I use for everyday gaming. These are my fingers. They're crooked due to a joint condition which I was born with. I wanted to make a way that was more comfortable for me to hold my mouse due to my condition, because it's very uncomfortable to hold it as it is. As a result, I've developed this grip, which you can attach to the side of the mouse, which is tailored towards the curvature of my fingers in order to make the grip more comfortable. I hope that this grip can be more accessible towards people who have similar conditions to me.
Yeah, so how did you model that?
I did this using 3D printing, and I created a 3D model after measuring the dimensions of my mouse and my fingers in order to make the best curve for me.
Alright, let's take a look. So that looks like a little friction fit you got in there.
Yeah, this attaches to the inside of the mouse, which has holes inside of it in order to reduce weight. This is what the mouse looks like with the grip attached, with my fingers able to rest on each side. This encourages a resting position for my palm in order to make sure that my fingers are as comfortable as they are. In order to make sure that there's not a lot of friction with the ground, I intentionally designed the grip to not reach the bottom of the mouse. Therefore, this is similar to using the mouse in a regular setting. However, you're just using a more comfortable grip, which would reduce wrist strain and make it more comfortable for people who have fingers like me.
Excellent, man.
Now, again, as I was saying, engineering design projects like just described must be considered a drop in the ocean. So this is where we have the students consider or to imagine dispositifs that might support their new innovation. And for the last few years, we've been focusing on having the students generate artistic representations of those dispositifs. And so you see a series of actants that are working in synchrony for each of the students' projects here. Now, we've had considerable success over the years with the STEPWISE project. We published a book in 2017, but its successes are limited and dependent on the existence of a mini dispositif as well. So you have to think of the STEPWISE pedagogy as a technology that is like a drop in the ocean. And so with support from local curriculum, Ontario has for several years included STSE education as part of their curriculum guidelines. That's been extremely helpful. Over the years, we've also developed a series of teaching and learning resources with teachers that have helped with success of the project with the pedagogy. And then we found that in our research that teachers who have more naturalist, anti-realist views of the nature of science will more likely allow their students to carry out student-led and open-ended projects or activities which is a key element of the stepwise pedagogy. So these sorts of things, working in synchrony, do help with the project. But we do think that much more needs to be done to expand the whole project. We need further interactions with, or even action research with, governments, transnational organizations, labor unions, workers, media personnel, youth action groups, and many more. If you'd like to learn more about Stepwise, there's the URL, stepwiser.ca. You can also write to me if have any questions. Email address is there. And finally, I have prepared a short paper that covers this presentation, and the link to that is here. It's again a tiny URL, RZ5ZJEM6. Anyway, thanks very much.